Hey guys, welcome to yet another video by Scaler, and in this particular video we're going to look into interview questions specifically on Amazon Web Services. So before we move on with this particular session, please make sure to subscribe to our channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. If you have any queries, leave a comment down below and we would love to help you out. So now, before moving on, let's just understand what exactly is going to be covered in this particular session. To start off with, we'll be covering certain basic AWS interview questions that we'll be understanding and asking few very basic questions like what is EC2 and what is this particular service and how it works. All these basic questions will be covered. And then we'll move on to the advanced questions and we'll understand even more services, and also services which are basic in nature, but we'll also look at them in a more in-depth manner. Okay, so this is what will be covered in this particular session. And also guys, did you know that we do have a blog where we are covering all of these insights and important questions and topics, where we exactly are covering AWS and AWS interview questions. So that is available in the description, the interview bit blogs. You can go check that out. So now let's just, before moving on, I'll just give you a brief about how exactly to address in an interview, because this is exactly about interview questions. It's not just about giving technical answers, right? You should also know how exactly to answer them and what not to answer. So first of all, take your time. So when they've asked you a really huge question which needs some time to think, do not go on and start speaking something which you already have a little bit of knowledge about. Just try thinking about it once, try to solve it in your head, and then go ahead, until and unless it's a quick knowledge based question. If it's a quick knowledge based question, obviously you have to give an answer really quick. If it's a lengthier question, then take your time and then answer. Give a proper answer. Second, ask questions. This is really important. Do not say I don't have any questions. Ask about what the company is doing. Ask about what are the current projects which are going on. Like obviously they won't give away all the details. They might give you one or two insights about it, right? Always ask questions. So these two are really important. Once that is done, then basically try to be more attentive to what exactly is going on, and also try to basically indulge in what exactly is going on. So do not say I don't know, or no, I do not know that. Just don't try to do those things. If you do not know an answer, try that. Try to saying like I do not know this, but I'm gonna learn this once I'm going to go out of this interview. And obviously if this is necessary for a job, I'll be able to learn it quickly as I'm a fast learner. So you'll have to basically try to turn your weakness into a strength. So that exactly is the last point which I want to talk about. Now, without any delays, let's begin with the session. So guys, we've understood what exactly is going to be covered in this session. So now let's start with the basic interview questions. So again, in the basic interview questions, some questions would be, the explanation would be less, some the explanation would be more, even though it's basic, so the explanations can differ. So you don't have to basically explain every single thing about a question which is asked to you. For example, let's say the first question is what is EC2? EC2 is the most common service. So it's the first service anybody would learn when they're getting into AWS. You might have learned a different service, but EC2 is the first thing most people would understand and learn when they are getting into AWS or any cloud platform. Virtual machines on cloud would be the first thing they'll be learning. So now, when somebody is asking you what is EC2, it's not necessary you'll have to explain every single thing from scratch. You don't have to tell them what exactly is a virtual machine first. Then you can tell, so that's exactly what we have replicated in cloud. Then you don't have to explain what is an hypervisor in order to tell them how exactly a virtual machine is created. You don't have to tell all that. You just have to tell them what is that particular answer for that particular question. So in this case, for the first question, which is what is EC2, the answer is EC2, a virtual machine in the cloud on which you have OS level control. So I think this particular line sums up everything. So it's a virtual machine which is running on the AWS cloud, for which you get OS level control. So you will be able to control the processes, you'll be able to install software, you'll be able to deinstall, uninstall software, you'll be able to manage everything around that particular virtual machine, right? So these are the things which you will be able to do. So you can run this cloud server wherever you want, and can be used when you need to deploy your own servers in the cloud, similar to your on-premises service, and when you want to have full control over the choice of hardware and the updates on the machine. So for example, let's say if it's an on-premises servers, right? So you would have complete control over them. Even the network would be yours. But when it comes to AWS, the network would be AWS's, but you would be basically given OS level control. That basically means sometimes you can also select
There's something called reserved instances and on spot instances, where you can also have authority over the choice of hardware, right? Even on-demand instances, that is normal virtual machine, gives you to choose the choice of hardware. That is, you can select how much storage you want, how much memory you want, how much virtual CPUs, that is cores, you want. You can choose all of those hardware components, but it wouldn't give you complete control over how exactly that is, because they wouldn't let you choose 3 GB or like 7 GB. There would be certain numbers. There would be 1 GB, 2 GB, 4 GB, 8 GB, 16 GB, like that. So you wouldn't be able to choose an odd number or something. So you wouldn't be able to modify it, but you will be able to choose what exactly you need. So to be very simple, the answer you will have to give in an interview would be, it's a virtual machine which is running on the cloud, and you have OS level control to it, so that you can install software. You can use it as a web server if you want to. You can use it as a database server if you want to. You can use it as any server you want to. You can also use it as a PC. You can use it as your own computer, normally how you use your own computer, right? So you can use it like that, because it's simply a virtual machine. You can literally do anything on it. So that's exactly what EC2 is. And EC2, the full form is Elastic Compute Cloud. So most probably you would know, and the person would know. It's not necessary that, first of all, Elastic Compute EC2 basically means Elastic Compute Cloud. You don't have to say that. It's not necessary, because I'm pretty sure most of you would have done this in an interview before. But moving further, you don't have to abbreviate something to someone when they're asking you something. You just have to explain what it is. Then they will understand you know it. You don't have to tell the full form, right? Okay. So now this is the first question. That's why I wanted to give you some insights about how exactly you can answer and frame your question. From here on out, I'll be just giving you the answers for the respective questions. So now, what is Snowball? So Snowball is not a feature, or it's not a inbuilt service like EC2 or S3 or RDS. Snowball is basically a small application that enables you to transfer terabytes of data inside and outside of the AWS environment. So it's a small application which runs on Snowball, which is a hardware device. So Snowball is a hardware device. For example, let's say you want to transfer terabytes or petabytes of data. What they do, basically, you can request to Amazon, that is, request to AWS. You need to transfer this much data. You would need Snowball. So they would be transferring Snowball to you, to your company's data center. You would be able to create a job. That is the first thing. You would be able to create a job, right? You would be able to create a job, and once you create a job, that transfer would go on by connecting to the Snowball, and the data would be copied to the device. So now once the data is copied to the device would be given to AWS, and AWS would basically upload it to S3, where your data would be successfully uploaded and stored. So that's basically it. It's pretty simple. This is what you can tell when somebody asks you what is Snowball. Okay, next comes CloudWatch. So what is CloudWatch? CloudWatch helps you monitor AWS environments like EC2, RDS instances, CPU utilization. It also triggers alarms depending on various metrics. So to be very, very simple, CloudWatch is a monitoring tool which essentially and especially monitors AWS resources. That's EC2, RDS, all of those resources would be monitored by CloudWatch, even if you haven't enabled, because CloudWatch is a free default service which is already running there, and it will basically give you all the details and metrics you need. For example, if you take EC2, you would be able to see how much network, that is network in, network out, how many packets have come in, how many packets have went out, the CPU utilization. There are so many other metrics which you can go through for every single AWS service you want to look into. There is also a paid part of it. For example, in certain resources, there would be something called enhanced monitoring, which you can select. Enhanced monitoring will give you even more in-depth monitoring ability, but that would be a paid one within CloudWatch. But usually you can just go with the free service if you're just practicing CloudWatch, right? And one more thing which is called alarms here. Alarms is basically a service, a feature built in CloudWatch. For example, let's say you have one EC2 instance, and whenever the CPU utilization of that one EC2 instance goes above 90%, you want another EC2 instance to be created. So in that case, you set up an alarm that will trigger itself when the CPU utilization of that particular instance goes above 90%. And when it goes above 90%, that obviously CloudWatch is monitoring, and it will get that data. And once it sees that it's crossed 90%, it will automatically basically it will send a request to EC2, and EC2 will launch another server, right? So this is how it works. So that's a basic example of what alarm is. Next is what is Elastic Transcoder. So Elastic Transcoder is an AWS service tool that helps you in changing a video's format and resolution to support various devices like tablets, smartphones, and laptops of different resolutions. For example, let's say you're creating an application and you want to have that application in that application you want a video streaming platform. Okay, so in that case, if you are uploading a video, usually let's say you are creating a web page, you are creating it for the desktop and you upload a video, and if you try to open that website in your mobile, right, all of your basically the resolution wouldn't, sometimes it wouldn't match, it would be kind of jumbled, it wouldn't be working properly. So you would be able to do, or you would be able to basically solve that using elastic transcoder. So that's basically this particular tool. Next comes VPC, what you understand by virtual private cloud. So it allows you to customize your networking configuration. So again, without networking, you can't do anything in AWS. So without networking, you can't do anything in AWS. To be very simple, if you are in a company, let's say even if you have an on-premises data center, without networks, you can't do anything, right? Because every single server is connected together because of a network. Without, so a network is basically that it's multiple servers connected together, or multiple computers or multiple clients connected together. So without a network, there can't be any communication between other computers. For example, without networking, there is no internet, right? So internet is basically a connection between other computers, right? So there are multiple routers which the internet goes through. There are various types of internet. Let's not discuss that. But again, without networking, you can't do anything in AWS. So the first and foremost important thing which you'll have to create, or it's already available in AWS, which is a VPC. So by default, there is something called a default VPC. When you start practicing AWS, you can use the default VPC. But if you are not using the default VPC, in that case, you can create another VPC and create subnets within it. So let's not cover subnets right now. When that question comes, I'll cover that. So VPC is a network that is logically isolated from other networks in the cloud. So even in your AWS account, if you have two VPCs, and let's say you create a server EC2 instance in VPC1 and EC2 instance in VPC2, so these two EC2 instances will not be able to communicate with each other because they are isolated from each other, because they are in two different networks, right? The only way they'll be able to communicate with each other, if the instances are public, they'll be able to communicate through the internet, right? If otherwise, there is something called a peering connection in VPC. You can create a connection between two VPCs, and these two instances will be able to communicate through that. Okay, so now it allows you to have your own private IP address, internet gateway, subnet, security groups. So these are all other concepts. So for now, when somebody asks you what exactly is VPC, you can tell that it basically lets you configure and customize your networking settings in AWS. And the foremost concept is basically it is logically isolated from other networks in AWS. Even within your account, it still isolates one VPC from another VPC, right? So when you create a VPC, you will be giving certain things, like you would be giving a CIDR notation. So within that CIDR notation, so your VPC will have a range of IP addresses. So whenever you create a resource within the VPC, the resource will have an IP address within that particular range, right? So these are the things. There are more things to VPC. VPC is a really huge concept, but when somebody asks you, these 3 points is more than enough. Just say it's the tool which is required to customize your networking configuration. It logically isolates that particular network from other networks in the cloud. Third one, it lets you basically create resources within it, and it will assign private IP addresses within the IP address range given to the VPC. Okay, so these are the things which you can take. Okay, next, DNS and load balancer services come under which type of cloud service? This is a pretty straightforward question. It will be a one sentence answer. So they are part of infrastructure as a service storage cloud service. Okay, so basically DNS, it's a domain name server. Next is load balancer. So what type of cloud service they are? So they are saying that they are infrastructure as a service. So infrastructure as a service in the sense they are providing you infrastructure over the internet. For example, EC2 is an infrastructure as a service. They are providing you a server over the internet which you will be able to use. So that basically is an infrastructure as a service. In this case, they are giving you a domain name server over the internet and a load balancer over the internet. So that they are also infrastructure as a service because they're infrastructural components. There are other services. There's platform as a service and software as a service. So we'll talk about that later. For now, whenever something relates to infrastructure, that basically means what does load balancer do? It balances the load and sends the what is that, the incoming requests across all the servers according to the rules you provided. For example, if you're just going with a classic load balancer, a traditional one, so let's say there are 100 requests coming in and there are two servers. So first request will go to the first server, second request will go to the second server. For example, let's say this is the cloud and users are trying to access the website which is running inside these servers. So when a first request comes in, it goes to server 1. Second request goes to server 2. Third request goes to server 3. So this is the traditional load balancer. So now load balancer does this, and that's why it basically is an infrastructural component which helps you do this. That's why it is an infrastructure as a service. It's not platform as a service because it doesn't provide you a platform to do some operations over it. It's not a software as a service because it's not a software at all. Software as a service, Gmail is a software as a service because it's a software given to you over the internet, right? So I think it's pretty clear they are infrastructure as a services. Next, what are the different storage classes available in S3? So right now there are around 6 storage classes: S3 standard, S3 intelligent tiering, S3 standard infrequent access, S3 one zone infrequent access, S3 glacier, and S3 glacier deep archive. So you can check out this. All of the storage are provided 11.9's SLA, and over here availability SLA is also provided. So SLA basically is service legal agreement, which basically means that Amazon is promising you that this particular resource will be available 99.9% of the time. So that's what they are giving you. So they are saying it wouldn't go down at all. Even if it goes down, it would be just for 0.01% of the time. And so let's not discuss more into it. Let me just briefly explain this. So that's all you have to say. So the storage classes are standard, which is the default storage class which will be given to you when you create a S3 bucket, right? And then there is intelligent tiering. There is standard infrequent access. So intelligent tiering basically is, you can see minimum storage duration is 30 days, and in this case the only difference between standard and intelligent tiering is it's a little more expensive, and it has a minimum duration period over here, but other than that they are pretty much the same. But standard infrequent access is different from standard because standard is considered as hot storage. That is, when you store something in standard, you are basically saying that that particular objects are frequently accessed by someone. But if you store in standard IA, which is standard infrequent access, so you are stating that it's not frequently accessed. Okay, so that's what you are stating. Yeah, so basically that's it. And then coming to one zone, so in these cases, the data will be available in 3 or more availability zones. But when it comes to S3 one zone, it will be stored in just one zone. So that's basically the storage class name. This is not a good practice, but sometimes if it's not important data or old history data, you just want to have it there on AWS, then you can have it on this. For example, in that case, if that availability zone was down, you wouldn't be able to retrieve that data in that particular period of time until AWS comes back up in that region. But that's a risk you would have to take because it's not designed for availability. You can see it's 99.5% of the time it's available. All the other services have 99.99. Intelligent tiering has 99.9. Glacier and Deep Archive have 99.99. So you can see the difference over availability because it's only available in one zone. Right. Okay. Next comes Glacier and Glacier Deep Archive. The only difference between Glacier and Glacier Deep Archive, you can see the time, the minimum duration, and one more would be the so this Glacier Deep Archive would be much cheaper than Glacier. Why? Because you will be able to download stuff of Glacier within minutes or hours, but in Glacier Deep Archive it will take several hours because Glacier is a backup service, backup storage service. You'll be able to back up your data. That's why the minimum storage duration for any data you store on Glacier is 90 days. You cannot delete them before 90 days. That's the minimum lock-in. When it comes to S3 Glacier Deep Archive, it's 180 days because these are data which you're archiving, which you don't want for now. You just want to archive them, like something company history data or project history data, whatever it is, you can just store over there, right? So these are different types of storage classes. What are explain uh, what T2 instances are. Okay, so T2 instances are one particular type of instance in EC2 instance types. There are so many different types. For now, let me just explain this. So T2 instances are designed to provide moderate baseline performance and the capability to burst to higher performance as required by the workload. So each types of instances will have a separate like what is it separate need to satisfy. So T2 instances are created to provide a baseline performance, that is regular performance, and also whenever the workload is increasing, they are equipped to give you a burst in performance which will increase the utilization of the CPU in order to provide you a better in order to provide a better handling of the workload, right? So that's exactly what it is. So these are the different types of instances within T2: dot nano, dot micro, small, medium, large, X large, and 2X large. So you can see, so this is virtual CPU. That basically means how many cores that particular instance has. So the nano, micro, and small have one core each. Medium and large have two core each, and large, X large, and 2X large have 4 and 8 core each. Right. So the difference between micro, small, and T2.small comes within the memory range and the CPU credits. So let's not go into CPU credits. That's a whole other concept. So memory. So let's just understand the storage and memory and the virtual CPU. So we already understood virtual CPU. So memory, you can see Nano has only 0.5 gigabytes of RAM. Micro is 1. Small is 2, medium is 4, 8, 16, 32, right? And performance low, low to moderate, low to moderate, low to moderate, low to moderate, moderate, moderate. So nothing gives you high network performance. All are nominal performances. So if it's for a practice project or a demo project, go with T2 instances. So also T2.micro is the free tier instance which is provided to you. This is the free tier instance which you will be able to use when you want your instance for free. All right, so these are basically T2 instances. Coming to the next question, what are key pairs in AWS? So when you create a virtual machine in AWS, you would have to create something called a key pair. If you already have a key pair, you don't have to create it. You can use the previous one which you already have. But if you do not have, you will have to create a key pair. Without that, you will not be able to create a virtual machine. So it is secure login information for your virtual machines. So how exactly it works? You will be given a public key and a private key. The public key will be stored in the virtual machine. The private key would be given to you that you will be downloading and storing in your local PC. So when you are trying to log in into the server, right, you will have to upload the private key. So it should be the same private key which is given to you, because only that particular private key will be able to decrypt the public key. Only if it's able to decrypt the public key, you will be given access to the instance, right? So that's exactly how it works. It's pretty simple. Private key, public key. With this private key, you will be able to decrypt the public key. Once it is decrypted, then you will be given access to the server. Then you can start using it. That's basically key pairs. It's pretty simple. Okay, now how many subnets can you have per VPC? So in a VPC, you can create subnets. So you can have about 200 subnets in a VPC, and also it's a matter of IP address ranges available. You can still have more, but again, if you want more subnets than this, you will have to consult. You will have to basically mail AWS support. But usually, by default, you will be given access to create 200 subnets per VPC. So subnets are basically sub networks within the VPC. Again, it's a logical concept, right? Even VPC itself is a logical concept. It logically isolates your resources. Same way, within a VPC, you can create something called subnets, which are subnetworks within the VPC, where you can even isolate the resources within the VPC from themselves. So let's say you can have 10 instances, and there can be two subnets, and 5 instances can be in one subnet, and another 5 can be in another subnet, and they can be also isolated from each other if they don't have any connection between them. So they can only privately communicate with each other if there is a communication portal between them. If not, they wouldn't be able to do it. So that's basically it. Okay, so you can have up to, so for this question the answer would be you can have 200 subnets per VPC. I just wanted to give you a brief about subnets. Okay, next is list different types of cloud services. This is a pretty straightforward question, and mostly it won't be asked in a again, it's a basic, but these are basic questions. That's why this question has come up. So software as a service, platform as a service, infrastructure as a service. These are the three essential ones. Data as a service could be added if you want to, because if you add data as a service, there are other types of cloud services which could be added, like function as a service, like big data as a service, AI as a service. You can add so many things, right? As a service is just a term. So mainly there are three types: software, platform, and infrastructure. When you talk about software, software on remote servers. For example, let's consider Gmail. The Gmail is running on a remote server on Google's data center somewhere. You don't know where that application is running. You don't know where the application's code is residing. You do not know where your emails are getting stored. It could be stored in any data center of Gmails. So you wouldn't know all that, but you will be still able to access the software itself, right? So that's basically software as a service. You will be given access to the software, but you will not be given access to anything else apart from that. You will only be able to use the software. Next comes platform as a service. So in this case, application development and deployment. So to be very simple, they'll in this case you'll be given a platform which will give you a little more access. So you'll be able to build something using this platform. For example, in AWS, there is a platform called Elastic Beanstalk. If you guys want, just type it in Google and see what exactly it is. So I'll just give you a brief. So it lets you upload your code and it will automatically provision instances, that is EC2 instances, and upload your code and install all the software necessary, and your website will be up in no time. You don't have to do anything else. You just have to upload your code properly, but your code has to be optimized for Elastic Beanstalk accordingly. But you all you have to do is create the application and upload it. Beanstalk will take care all of it. That's the infrastructural part would be taken care of Beanstalk. So the only thing you will have to worry about is the platform, handling the platform, right? So that's basically platform as a service. Now coming to infrastructure as a service, as I already explained to you what is EC2. So servers, storage, operating systems. So S3, EC2. So these two are basically infrastructure as a services. So S3 basically provides you storage. You will be able to upload and download and delete and do every operation which you can basically do in your own personal computer. So it lets you do all that. They're providing infrastructure via storage. EC2 gives you infrastructure via servers. So in this case, what they are basically doing is they're giving you, like let's say they're giving you operating system level access to servers. So that's exactly what infrastructure as a service is. In this case, you will be given the access to the server itself. For example, in this case, you only get access to the software, the only the platform. Here you get access to the infrastructure itself. You can install any software on it as you want. Okay, so now we've seen the basic questions. I hope the basic questions were helpful. Now let's move on to the advanced questions. Right. So also at the end of this particular session, guys, I'd be asking you a question. So if you know the question, please put down in the comment section. I'd be asking it to you. So for now, let's just try to understand everything about AWS interview questions. Now moving on, we'll be looking into advanced questions. So make sure you understand the basic questions. Make sure you just go ahead and check the documentation, just cross-reference everything. So I've given you the answers, right? You just cross-reference everything, make sure everything is clear for you, because some of these questions are pretty small. If you want to know more about key pairs, go to the documentation and learn more about key pairs. But we are just trying to give you answers for the questions asked, right? All right, so now advanced AWS interview questions. Okay, explain what S3 is. So S3, it's called a simple storage service. So S3 is basically a storage service where you can store, retrieve, delete any amount of data. Basically, virtually unlimited data can be uploaded and downloaded like at any time using the internet. So basically, the payment is pay as you go for most of AWS services. So especially in S3. So basically, let's say you upload 2 gigabytes of data, you only have to pay for the 2 gigabytes of data which is uploaded. And if you deleted that, you don't have to pay anything because there is nothing stored on AWS at that point of time. So basically, you only pay for what you use on S3. So in this case, why I say virtually unlimited is you do not know how much storage space that AWS have. You can literally keep uploading how much ever data you want. AWS wouldn't stop you because obviously you are going to pay them for the data which you are storing, right? So they obviously are a for-profit business who are profiting from this. So they will provide you unlimited, virtually unlimited, because there will obviously be a limit to the data which you can store, which would be really high. You wouldn't have that much data to store, obviously. But again, that's basically what S3 is. It's a storage service which lets you store petabytes or even exabytes of data on it, and you just have to pay for what you use. Okay, next question. How long does Amazon Route 53 provide high availability and low latency? Okay, so the question basically is, how does it provide high availability and low latency? Why should I not go with GoDaddy or any other DNS service, right? Why should I choose Amazon Route 53? So now they're explaining that. So first of all, it provides a globally distributed service. AWS again is the biggest cloud network right now, uh, and obviously they have data centers all around the globe in most of the countries, and they literally have in every single continent, right? They have data centers in every single continent, so that basically helps them serve your website to every single person around the world. You'll be able to serve your website. Let's say you're in India, you're creating a website and you want your product to go global, and you want your application to be available for every single person around the globe. So you can use Route 53 to do that. Next comes dependency, and finally optimal locations. Now let's come from the top. So Amazon is a global service and consequently has DNS service globally. As I told you, they have data centers all around the globe. Any customer creating a query from any part of the world gets to reach a DNS server local to them that provides low latency. So low latency in the sense, they're asking how exactly Amazon Route 53 helps you in order to make sure your application is really fast for any user around the globe. So if the application is if the headquarters is in India, the main customer base in India, so then it makes sense to provide low latency to customers in India. But how exactly Route 53 provides low latency to every single person in the world if you're using this application in a global level? So that's how it is doing, by providing them a local server which is nearby them. So they'll be taken to the local server. From there, they'll be routed to the actual place where the website is hosted, or they could just, if the website is available globally, then the local server itself would be able to give them the access to the website. So that's basically how low latency is maintained. Dependency, Route 53 provides a high level of dependability required by critical applications. So again, you're paying AWS for something. They are the cloud leader right now, so obviously the dependency is there. They give you a high level of dependability required by critical applications. Even though it's a critical application, you could run on Route 53 and it will make sure it is running really well. That provides the website high availability. And finally, optimal locations. So Route 53 serves the request from the nearest data center to the client sending the request. Whenever a client sends a request, let's say my main customer base is in India, and there's a customer from, let's say, Ethiopia trying to basically send a request, and they're sending a request, and they'll be taken to the nearest data center to them, so that it's much faster for them to get the website shown in their browser, right? So AWS data centers are across the world. The data can be cached on different data centers located in different regions of the world, depending on the requirements and the configuration chosen. Route 53 enables any server in any data center which has the required data to respond. This way, it enables the nearest server to serve the client request, that reducing the time taken to serve. It's basically caching. So the website will be cached in the nearest local server, and as it is already cached, it doesn't have to travel all the way to the original server to get the data back. It can just use the cached information and just return it to the user. That would be quick, and the user would be happy about it, right? So this is how Route 53 does it. So there is obviously more to it. That's what we're going to look at right now. For example, let's consider, please cut that small part which I didn't speak. Okay, so now let's consider the requests are coming from a user in India or served from the Singapore server. while the requests coming from a user in the US are routed to the Oregon region. For example, uh, let's say the application is in the US, right? The application is in the US. So now this is the Oregon data center. This is the Singapore data center. So let's say this website is not available in Indian data centers. So now a user is basically trying to request, right, some data or the website. So the user is requesting from India. So request from user routed to Oregon region. So this is basically for this. So now when a request comes from the Indian user, Route 53 checks for the nearest server. So the nearest server this time would be Singapore. So in this case, the request from the Indian user would be redirected to the Singapore server and the data would be given back to the user as fast as it can. But if a user from the US region itself is trying to access, they will be taken to the nearest server. In this case, it's Oregon. So this is how it maintains high availability and low latency. So this is especially for low latency, not high availability. For high availability, there are so many different things which you can talk about. Uh, Other AWS, so there are multiple data centers, so your application can be replicated in multiple data centers, even though one data center is not available. For example, even though if the Singapore data center was not available at that particular point of time, Route 53 would have taken them to the next nearest server, right? Next nearest data center. So that's exactly how it provides high availability. Okay, so now coming to the next question, how can you send a request to Amazon S3? So it's a REST service, and you can send a request by using the REST API, which is available, or you can use by using the AWS SDK wrapper libraries that wrap the underlying Amazon S3 REST API. So basically, you can use the REST API manually in order to do it, or you can use AWS SDK, and you can basically create a piece of code, and you can use that code. Whenever you run that code, it will send a request of whatever request you want to by using the wrapper libraries which you have created, right? So that's how you can do it. Moving to the next question, what does AMI include? So first of all, AMI basically means Amazon Mission Image. So an AMI includes the following things: template for the root volume for the instance. So how exactly the root volume should be formed, how much storage it should have, and what are the things which it should have. Okay. Second, launch permissions to decide which AWS accounts can avail the AMI to launch instances. So when you create an AMI, you can choose whether it's public or private. If it's private, only that particular AWS account would be able to do it, but that particular AWS account would be able to give access to another AWS account even though it's private. But you can also convert it into a public AMI. In that case, every single person in the world would be able to use your AMI to create a or launch an instance. Now, a block device mapping that determines the volumes to attach to the instance when it is launched. So whenever the instance launches, it needs some volume to be attached, right? So that particular volume is basically so that information is also stored in the Amazon Mission Image. So basically, when you use the Amazon Mission Image, you can launch one instance or you can launch multiple instances according to whatever is your requirement. But the AMI will contain all of these things: the template for the root volume, the permissions to launch in whatever AWS accounts, and finally the block device mapping, that is what are the different types of block devices which needs to be attached to this instance. So when the AMI is creating, it will also basically launch the volumes and attach it to itself. So this is basically what an AMI is, right? If you want to know more about AMI, you can go check it out. So what exactly AMI is? It's a template which is used to create instances. So you can't create an EC2 instance without an AMI. Okay, so that's basically AMI. Coming to the next question, what are the different types of instances? So we saw one type of instance. So that is one singular type of instance, but these are basically the groups, the types. So basically groups in types of instances. So there is a compute optimized, there is a memory optimized, storage optimized, accelerated computing, and general purpose. So the T2 instance type, which we previously saw, was a general purpose type of instance, which is basically used for generic usage, and also it will provide you a burst in performance whenever required, but it's mostly basic. But compute optimized will basically provide you really good processing power. So basically it will provide you more CPU cores than the RAM provided. Okay, so that's basically compute optimized. It will be optimized for compute. Memory optimized is optimized for memory. That is, it will give you more RAM but the cores will be less. The virtual CPUs would be, the number of the virtual CPUs would be comparatively less than the RAM. So this is for memory. So if there is any in-memory processing, you would have to choose a memory optimized instance type. Storage optimized, this is for storage. So for example, in this particular EC2 instance, there is often data coming in, data going out. You want the data read and write to be really, really fast. In that case, you should go for storage optimized. So that's exactly why you should go for that. Finally, the accelerated computing. So this is basically for example, if you're running an artificial intelligence model or a machine learning model, or if you're transcoding videos, or if you're rendering videos or graphics on the server. In that case, you would need accelerated computing, which would provide you a really high performance for these kinds of requirements, right? So these are different types of instances. Coming to the 17th question, what is the relation between the availability zone and the region? So to put it very simply, the region is the entire region. So there could be so the regions are geographical. Within the region, there could be any number of data centers, but usually around there are 6 to 7 data centers in AWS. So an AWS availability zone is a physical location where an Amazon data center is located. On the other hand, an AWS region is a collection or group of availability zones. For example, let's consider in US there are so many different states. So for example, when they say Oregon, right? In Oregon, there could be multiple data centers in different physical locations, but the group of them in that particular region. So that region, Oregon, is the region, and within that there are multiple availability zones. So they are the availability zones. That's basically it. Availability zones are individual data centers. Region is just to group them together. Okay, so this setup helps your services to be more available, as you can place your virtual machines in different data centers in even different AWS regions. So you can have your data center in Oregon, you can have it in North Virginia, you can have one more server in India, you can have one more server in Japan. So it totally depends on whatever is your requirement. So that's what they are saying. If one of the data center fails, the other one would be running, so that your servers would be always running, and that will make it always available. So this basically provides the failover. It provides you fault tolerance. Even though your server in a particular region goes down, your application wouldn't completely shut down, because there are other regions and other data centers which are actively running. This is basically the difference. It's not a difference basically, because availability zone is within a region. Region is a logical group, but within the logical group there are physical components, which is an availability zone. Next question, how do you monitor VPC? So as I told you already, there is CloudWatch. It's the default tool, but VPC has a separate function, which is VPC flow logs, which will give every single action performed within the VPC as a log. So you can see every single action done in that particular VPC with flow logs. So these are the two different ways you can monitor VPC. So what are the different types of EC2 instances based on their costs? Essentially three types: on-demand, spot, and reserved. On-demand instances are when they are prepared whenever you need. So you can, if I want an instance right now, I can log in AWS and create an instance. That would be an on-demand instance. So that would be created for a short period of time. So basically, on-demand instances are created for short-term requirements. For example, if I currently want to run a particular code and I want to just run a website for a couple of hours just to test it, so then I would go with an on-demand instance, because on-demand instances are more expensive than spot or reserved instances. Let me tell you why when we come to spot or reserved, but they are expensive. So it is cheap for a short-term instance, but it is not cheap for the long term. It will get much more expensive. So that's basically on demand. Coming to spot instances, so these types of instances can be bought through a bidding model. These are comparatively cheaper than on-demand instances. So in this case, you will have to bid for the instance, and if the instance is available, you will be given access to it. So once you win the bid, you will be able to pay for the instance. Basically, that particular bid amount you will be able to pay. Right? So these are spot instances, but reserved instances are the one which companies mostly use for their needs. So why? Because reserved instances are reserved for you. For example, a company wouldn't be like, okay, if I want an instance right now, they wouldn't go right now and create it. They would already reserve some physical hardware which is already available. For example, you can create instances that you can reserve for a year or so. These types of instances are especially useful when you know in advance that you will be needing an instance for the long term. In such cases, you can create a reserved instance and save heavily on costs. Why save heavily on costs? Because when you reserve instances, AWS gives you discounts like 40 to 50%. That's a lot of money, right? Which you can save, and a company wants to obviously cut down on operational costs, and they will always go for reserved instances. For example, let's say there's a new project coming up, and obviously, if a new project comes up, the project will be always live, right? So to once for maybe for the testing and all you can use an on-demand instance, but when it comes to live, obviously reserved instance would be a much better chance, because if the application is going to be live for a long time, you can take a 3-year reserved instance. It won't be one instance. When it comes to a company, it will be hundred or thousands of instances, basically servers. So in this case, you would be reserving them uh, by using by basically using the reserved instances tactic, where you can basically reserve these number of instances for this period of time, that is 1 year or 3 year. You can put a contract with AWS, and you can pay them upfront or you can pay them monthly, or there are different types of paying models in reserved instances, but it will be much cheaper than going with on-demand instances. It will save you, if it's a 3-year contract, it will save you more than a 1-year contract, because you're reserving instances for a 3-year period of time, right? So these are basically different types of instance based on costs. Coming to the next question, what do you understand by stopping and terminating an EC2 instance? Really easy question, but it comes with certain complications. Even though stopping and terminating may sound similar, but in EC2, it's totally different. Stopping is basically shutting down your system. For example, if you shut down your system and restart it, the PC is still there, right? If I shut down my laptop and open it back and switch it on, it'll still switch on, the instance will still be available. It'll have the storage, it'll have all my files, everything will be there. You can just start from where you left off. But terminating is basically like selling your laptop to another person or breaking your laptop. So once you break your laptop, you can't do anything to it because it doesn't exist, right? So that's basically what terminating is. You're completely deleting the instance, and so nothing would be available. The instance would be deleted, the data would be deleted, this volume will be deleted, everything will be deleted. You would not be able to restart or look into the system later in time. So that's basically the difference in stopping and terminating in EC2. I hope that's clear. Okay, coming to the next question, what are the consistency models offered for modern databases uh, by AWS? So eventual consistency and strong consistency. So coming to eventual consistency, it basically means the data will be consistent eventually, but not immediately. So let's say there are two databases. If I upload some data to this database, I want it to be available in this database as well. But eventual consistency basically means it will get consistent eventually in time, but once I upload it, it won't be immediately replicated. It will take some time to replicate it. So this will serve the client requests faster, but chances are that some of the initial read requests may read stale data because that data wouldn't be available at that point of time, because it's not transferred to the other database. So this type of consistency is preferred in systems where data need not be real time. So if you don't want the data to be real time in a particular system, in that case, you wouldn't want this. So you would want this type of consistency. For example, if you don't see the recent tweets on Twitter or recent posts on Facebook for a couple of seconds, it is acceptable. So that's where eventual consistency comes into play, because it's not gonna kill anybody, right? It's not a thing which is required immediately. So let's say you're posting something right now and it takes 2 seconds to show up on your profile. That wouldn't hurt anybody, right? So that's basically what eventual consistency is. But strong consistency, it provides immediate consistency where the data will be consistent across all of your database servers immediately. As soon as you upload to a database server, it will be immediately replicated to the other database servers. Okay, so this model may take some time to make the data consistent and subsequently start serving the requests. So eventual consistency, the data will be available in one database server, but it will take time to replicate to other database servers. So in that case, the data can still be read from that particular database server. But when it comes to strong consistency, as the database servers are currently trying to become consistent by basically replicating it across each other. So when you are trying to request some data, It would take some time because it is trying to make every database server consistent. So however, in this model, it is guaranteed that every single response you get will have consistent data. In the previous one, even though let's say it takes a couple of seconds to show up, it's fine because it's not real time. But in this case, strong consistency, you would need you basically use it for a real time use case. Okay, so this is the difference in consistency models offered. Okay, next question, geo-targeting in CloudFront. So geo-targeting enables the creation of customized content based on the geographic location of the user. This allows you to serve the content which is more relevant to a user. For example, if you take YouTube, some content is available in US, but you won't be able to see that content in India. Or take Netflix, some movies are available in Europe, those movies are not available in China, or that movies are not available in Japan. Why is that? They're using geo-targeting, right? By using geo-targeting, you can basically serve the relevant content to your user. And also, if it's an Indian YouTuber, it wouldn't make sense to show particular YouTuber, that particular YouTuber's content to a American, right? Especially if it's in an Indian language, they wouldn't be watching it. So it doesn't make sense. So by using geo-targeting, you would be able to deliver content in a proper manner based on the geographic location of the user. For example, using geo-targeting, you can show the news related to local body elections to a user sitting in India, which may not be suitable for a user sitting in the US. Why would they want to watch a local body election happening in India? Same thing if there is a baseball tournament in the US which is going on. We Indians don't play baseball. We play cricket and other sports like football and stuff like that. So maybe if it's a football game, we would watch it. But if it's a baseball game, most probably we wouldn't. So yeah, so that's basically is geo-targeting, right? Okay, coming to the next question, what are the advantages of AWS IAM? So IAM means Identity and Access Management. So it enables an administrator in AWS to provide granular level access to different users and groups. So using IAM, you will be able to provide access to a user you created in IAM. So you can basically create users, you can create groups, and once you do that, you can give them permissions to do certain actions. For example, you want to allow a user to basically work only on EC2. You don't want him to work on other services. You can do that. You can provide him permissions to only use EC2. He wouldn't be able to use other services, right? So that you can do with IAM. So it also allows you to provide access to the resources to users and applications without creating roles, which is known as federated access. Also, there is something called IAM roles, which could provide an user temporary access to that particular service you want them to use. Right? It's temporary access. It's not permanent. So there are more things to IAM. So, but the advantages are you can create users and groups, and you can control the users by you can basically have access to them, and you can have basically you can provide them different level of access according to the user. For example, a developer would need different types of AWS services. Data scientist would need different types of AWS services. Let's say a finance account manager would need different types of AWS services. So according to that, you can provide them particular access. So that's basically what are the advantages of AWS IAM. You would be able to basically administer over users and the permissions they have. Coming to the next question, what do you understand by a security group? So to be very simple, security group is basically like a virtual firewall. So when you create an AWS instance, you may or may not want that instance to be accessible from the public network. Moreover, you may want that instance to be accessible from some networks and not from others. For example, you are creating an instance and only you want to access it. So you know the IP address of your PC, right? So in that case, you can create in the security group, you can pass on your IP address and only you would be able to log in into that EC2 instance, even though somebody else has a private key. Let's say you have given the private key to someone else, they wouldn't be able to log in because they wouldn't have the IP address. Now, coming to second point, security groups are type of rule-based virtual firewall using which you can control access to your instances. So you can create rules defining the port numbers, networks, or protocols from which you want to allow access or deny access. Okay, so it's basically simple. You can provide the port numbers, you can provide the IP addresses, the protocols, all the things you can provide. So this will basically and also you can allow them or deny them. So let's say if you want a particular range of IP address to be denied, whenever a request comes from that IP address, they wouldn't be allowed to access the instance because the security group will stop them. So it's basically very simple. You can control who can access and who can't access the instance, and where the request goes, where the request comes, everything can be accessed using a security group. Okay. Now, what are spot instances and on-demand instances? So I think we already looked into this, but I'll just explain what are spot instances even better. The on-demand I've already explained in a previous question. You can go check that. So spot instances, while you create EC2 instances, there are some blocks of computing capacity and processing power left unused. So let's say you launch a really huge instance, but only utilize one certain part. So now these blocks are known as spot instances. So these spot instances run wherever capacity is available. So these are a good option if you are flexible about your where your applications run. If you don't want your application to be running in a physical hardware which is dedicated to you, in that case you can go for spot instances which are much cheaper in nature, right? So yeah, so if you're flexible with that, you can go with spot instances. So that's basically it. On-demand instances are I've already explained, and you can look into them. You can just go back in the session and you can look into them. Right. Next is explain connection draining. So connection draining is a feature by AWS which enables your servers which are either going to be updated or removed to serve current requests. So that basically means, let's say your server, right, it is going to be updated to a newer version, but connections are still coming in, so it will still allow the server to basically serve those requests. So if connection draining is enabled, the load balancer will allow an ongoing instance to complete the current requests for a specific period of time. For example, you can set that up. It will allow, let's say, the incoming request, it will serve for 10 minutes and then but will not send any new request to it. So if already 100 requests have been made, right? So it will allow those 100 requests to be served, but after that, it wouldn't let any new requests to come in, but that 100 requests will be served. Once it is served, then it will be stopped. So now without connection draining, an outgoing instance will immediately go off and the requests pending on that instance will error out. So that would be a major problem for users, right? So because if you're trying to retrieve some data and the application was working at that point of time, so once you click on retrieve data and it doesn't give you the data, you would be kind of pissed off. So, but in this case, using connection draining, that wouldn't happen. If the system is going to be updated, you would get back the data and then it will go to an off state where it's in maintenance. So otherwise, you would get the request back. So this is basically connection draining, and this feature is available in load balancer. Next, what is a stateful and a stateless firewall? A stateful firewall is basically the one that maintains the state of the rules defined. It requires you to define only inbound rules. Based on the inbound rules, it automatically allows the outbound traffic to flow. So you only have to mention the inbound rules. Basically means you only have to decide on the incoming traffic. So it'll automatically choose, or it'll automatically filter the outgoing traffic, but the only thing you'll have to provide is the incoming traffic rules. So who can access the server from where you don't want, so who can't access the server, all of these things you will have to do, but the outgoing from the server will be taken care of the system itself. So that's basically stateful. In stateless, you explicitly define rules. That is, you can basically decide what are the IP addresses, what are the things which comes in, and what are the things which goes out. Everything could be handled by you, but you will have to do it by yourself. You have to explicitly define those rules. For example, if you allow inbound traffic for port number 80, stateful firewall will allow outbound traffic to port 80, but stateless firewall will not do it, because in stateless firewall, if you provide inbound traffic for port number 80 and leave it, it will only allow inbound traffic for port number 80. But if in stateless firewall, you will have to go ahead and explicitly mention that also I need output traffic for port number 80, right? Once you do that, then it will allow. But in stateful, you basically means if you mention something, if somebody can enter the instance, right? Somebody can inbound, they can also go out. So that's basically what stateful does. Stateless doesn't do it. In stateless, you have to give every single detail manually. Coming to the 28th question, what is a power user? Access in AWS. So it's pretty simple. It's like a sudo user in Linux. So a power user will be given administrator access. So using IAM, you are creating a user. Once you create a user, you can give them administrator access. So once you give them administrator access, they can do everything the root user does. Only thing they can't do is like they can't delete the AWS account. They can't check out the billing dashboard. So those are the things they can't check out, but they can do everything else apart from those. So without the capability to manage the users and permissions. In other words, a user with power user access can create, delete, modify, or see the resources, but he cannot grant permissions to other users. So he'll not be able to create other users and grant permissions to other users, but he'll have all the access to use any service in AWS he wants or she wants, right? Okay. Next question is what is an instance store volume and an EBS volume? So it's basically two different things. So instance store volume is a temporary storage. Only temporary data is stored because let's say the instance is restarted, that data will be gone. That is the instance store. It's like RAM. But EBS volume is like your SSD or your HDD. So once the data is stored, it is stored there because it's a storage disk, and once it is stored, even though the instance gets turned off, it will be available. That's the only difference. Instance store is like RAM. When the instance is running, when temporary data is available, it will be stored in the instance store. Once your instance is restarted or it's shut down, that data will be gone, but whatever data is stored in the EBS volume will still be there. 30th question. What are recovery time objective and recovery point objective in AWS? So recovery time objective. It is the maximum acceptable delay between the interruption of service and restoration of service. This translates to an acceptable time window when the service can be unavailable. For example, recovery time objective, let's say AWS tells you that 5 minutes per day. So you can expect that the service will not be available for 5 minutes in a day, but it is not acceptable if it goes beyond that 5 minutes. So if it goes beyond that 5 minutes, you will be able to get a refund or whatever from AWS, but that's the limit given to you. So but it's 5 minutes per day, it's also a lot of time. So that's not the case, it's totally different, but I'm just giving you an example. Next is recovery point objective. So in this case, it is the maximum acceptable amount of time since the last data restore point. It translates to the acceptable amount of data loss which lies between the lost recovery point, and the interruption of service. Let's say data is being uploaded and the service has been interrupted. So there would be obviously some data loss, right? So how much data can be lost? How much data loss is acceptable? That's basically a recovery point objective. So these two things has to be given to you when you are trying to create a mission critical application on AWS, because mission critical data can be lost, mission critical applications might be interrupted of service. So these are the things which you'll have to discuss with the AWS team, AWS sales team, the tech team, everything before you basically transition all your stuff into AWS, right? 31st question. Is there a way to upload a file that is greater than 100 megabytes in S3? So in S3, at one go, you can't upload files more than 100 megabytes, but there's an option to do this, which is multi-part upload utility. So it will split the large file into multiple parts. Let's say you're uploading a file of 1 gigabyte, which is 1024 megabytes, right? It will split it into 10 parts and it'll upload it, or it will split it into 11 parts and upload it, and then once it's uploaded, it will be clubbed together. So you can also upload decrease upload time by uploading these parts in parallel. uh, so in this case, larger files can be uploaded in multiple parts that are uploaded independently. So if you want to reduce the time, you can upload those 11 files at the same time, and then you can club them together. After the upload is done, the parts are merged into a single object or file to create the original file from which the parts were created. So you can use multi-part upload to upload a really huge file. Coming to the 32nd question. Can you change the private IP address of the EC2 instance while it is running or in a stop state? So first of all, once you created an EC2 instance and once a private IP address is assigned, you will not be able to change the private IP address. When an EC2 instance is launched, a private IP address is assigned to it. So once it is assigned, you will not be able to change it because it is attached to the instance for its entire lifetime. So once it's terminated, you can create another instance and that instance can have the same private IP because this instance is dead, it's not available. and the private IP address is free now, so it can be assigned to another uh, a server, but that server cannot have a different private IP address. It can have the same. It will only have the same IP address. 33rd question. So what is the use of lifecycle hooks in autoscaling? So lifecycle hooks are used for autoscaling to put an additional wait time to scale in or scale out event. To make it even simpler, let me just explain using this particular thing. So this is a lifecycle hook and this is a lifecycle hook, right? First of all, scale out. Scale out basically means decreasing the number of instances. Let's say you have 5 instances. Now you don't need 5 instances, you want only 3 instances. So now you are reducing 2 instances, right? Now scale out pending. So lifecycle hook basically pending wait, pending proceed. So it is basically the instances are launching. So sorry, scale out basically means increasing the number of instances. Sorry, my mistake. So once then the instance, once it is launched, it would be in service, and then scaler comes in. So in this case, there is another lifecycle hook which is for terminating. First, once the terminating is started, it'll wait, and then it'll check how many instances has to be terminated. So once that is decided, it'll terminate the instances, and then termination will be done. So in an auto scaling instance, so this is what happens. So it basically gives you an additional wait time to scale in or scale out. That's exactly what lifecycle hooks does, and that's exactly what it helps. And the final question, which you're going to look into, is what are the policies that you can set for your users' passwords? Okay, so you're, let's say, using IAM, you're creating a user's passwords. So what are the different kinds of settings you can do to that user's password so that they create a secure password? First of all, you can provide a minimum length. If you want the minimum length of the password to be 10 characters, you can do that. Second, you can ask the users to add at least one number or special character. Third, you can provide a requirement like a particular character type like @ or hashtag or forward slash or backward slash. So you can provide that you need at least these, or you need uppercase letters, lowercase letters, numbers, and non-alphanumeric characters. So you can ask these requirements. Fourth, you can enforce automatic password expiration. That is, you can set up a password expiration period. After every month, they'll have to change a new password. That's basically the fourth one. And the final one is you can have the AWS users contact an account administrator when the user has allowed the password to expire. So basically, you don't have to manually change the password. You can allow them. So you can basically give the access to the account administrator when the user has allowed the password to expire, right? So if the user allowed the password to expire, then they will be able to contact the account administrator and get their password back if they are not able to create a new password. So these are the different types of things. These are different policies which AWS administrator can set to the IAM users, right? So these are basically the questions, guys. So now coming to the final part, I'm going to ask you a question. So if you know the answer, put down in the question section and we would give you a heart from our side to recognize that yes, that's the right answer. So the question basically is, which of the following is an edge storage or content delivery network? So which of the following is an edge storage or content delivery system that caches data in different physical locations? Four options: relational database service, DynamoDB, CloudFront, associate web services. So I'll repeat it again. Which of the following is an edge storage or content delivery or CDN that caches data in different physical locations? So is it RDS or DynamoDB, CloudFront, or associate web services? If you know the answer, put it in the comment section. So that's basically the session, guys. I hope it was helpful. So meet you in another one. And if you like the session, please leave a like. Thank you.